Guys at home, can I get a thumbs up that you hear me and see the board okay? All right, here we go. Did you have a hand or anything? No, okay. All right, so guys, I showed you all the parent graphs for tangent, cotangent, secant, and cosecant. Now you have to transform them. I'm going to show you how to do it by hand. However, on your homework, the majority of it is you're picking it out of 4 multiple choice options. So as long as you know really how to identify what the new period is, what any type of transformation, shifting, or stretching happens, you should be able to pick it off out of the multiple choice without graphing it by hand, but you still should have an idea as to how to put these graphs together regardless, all right? I'm going to try and get through 2 graphs today. Let's see if we can do it. All right, so guys, we're going to be graphing transformations of these forms. So when you look at their parent functions, this A value is new, this omega value is new, and this beta is new. They will have some type of effect on the graph when you make these changes to the equation. So the A value is on the outside. It's going to be timesing with your y's. So it's going to result in some type of vertical stretch or shrink. We don't have to talk about the amplitude because these 4 functions go off to the infinities, so they don't really have an amplitude that we discuss. All right, the omega, it's inside the function, so it's definitely happening to your x values, but remember, it always has the opposite effect of what it looks. So if it's omega times x, your x's in reality are being divided by omega, so it's going to cause some type of horizontal stretch or shrink. Also, if you take the x values and you divide them by something, it's going to change the period. It's going to change the amount of inputs it takes to create one cycle or one period. So that's a huge thing you have to watch out for. And then the beta on the outside of the function is affecting your y coordinates. You'll be adding it to your y coordinates, so it'll take the graph and it'll shift it up or down so many units. And then just another reminder, when you're dealing with the A value, that is what you're timesing your y's by, so you're making them bigger or smaller. But if A is negative, it's also going to cause an x-axis reflection on top of that. Okay? All right. So the first graph we're going to look at is we're going to graph y equals 3 times the tangent of 2x. So obviously some changes have been made to the parent function, so there's going to be changes made to his graph. All right, I want to move this up to give myself as much workspace as possible. Let's do it. Okay. Our book is very, very big on you guys being able to graph using transformation. So that's what I'm going to show you to do. So what we want to do is get ourselves all set up. We want to remember what the parent graph looks like so we can make the appropriate changes. So let's get all of our base information going. If we look at the parent, which was the graph of y equals the tangent x, right? If we take all those changes out. I always like to have this near me. Okay? You want to recall, what did the first cycle or the first period of the tangent graph look like? Well, guys, first of all, do you remember the period? How many units did it take for the tangent or the cotangent graph to repeat? It took pi units. Remember, it had a faster period. It repeated quicker. All right, so if you took that period and divided it by 4 into 4 subintervals, we were counting by increments of pi over 4. So every pi over 4 units, there was a critical or key point on the parent function's graph. All right, well, guys, if you look and you're trying to remember it, you should have some visual of it. Tangent graph was sandwiched in between 2 vertical asymptotes and was an increasing function. It went from -1 to 0 to 1. And it kind of did that in an increasing direction. That's what the tangent graph looked like on his first cycle. So we're looking for this asymptote. So guys, at 0, the tangent would be y over x. That's 0, 1. So it didn't start at 0, the first cycle. So then let's go backwards at negative pi over 2, right? At negative pi over 2, what was the tangent? -1 over 0, that's undefined. That was our first critical point. So our first critical point happened at negative pi over 2, undefined. That's where that asymptote was. Right, and then from there, we counted by pi's over 4, and we got the other critical points. So then it went negative pi over 4, negative 1, that was that point right there. Then it went 0, and then the tangent at 0 was 0. That's that point right there. Then it went pi over 4, 1. That's this point right there. And then it went pi over 2, and at pi over 2, the tangent y over x is undefined. That's that asymptote. So those were the 5 key points that made up the first period of the tangent function. Now, guys, you're going to have your notes. That's written in our notes. So if you're like, how am I going to remember that? You'll have it written down. All right? So those are the 5 key points. Now let's figure out, well, what are the changes? What effect are they going to have on these ordered pairs? So, guys, we have 3 on the outside, which will be timesing our y's. So we're going to have 3 times the y's. That's going to cause a vertical stretch. The y's are going to get 3 times as big. All right, then it looks like there's no adding or subtracting of a number, so it's not being shifted up or down. That's the only thing happening to y. And then the only other change is 2 times x. But in reality, our x's are being divided by 2. So you can think of it as x's being divided by 2, or sometimes it's easier to think of it as the x's are being times by a half, because it's easier sometimes to times fractions by a half than it is to divide them by 2. All right, well, now you got to figure out what's your new period. Because if you're dividing your x's in half, you're causing a horizontal shrink. You're making the x's smaller. So that means the period should get smaller. It shouldn't take pi units anymore to create one tangent curve. So what's our new period going to be? Well, to get your new period, you take the old period, which was pi, and you just do whatever you did to your x's. I'm dividing my x's by 2. So take your old period and divide it by 2. All right, that means our new period is pi over 2. Now it only takes pi over 2 units to create one cycle of the tangent curve. Okay, well, what's our counting increment going to mean? So our counting increment, if you take pi over 2 and you divide it into 4 subintervals, right? What's our counting increment? Well, guys, it's easier to just take pi over 2 and times it by a 4th. That's the same thing as dividing it by 4. And you're going to get pi over 8. Pi over 8 is going to be your new counting increment. So let's get our x-axis set up to be ready for these new points. So we're going to count by pi's over 8. So this is going to be 1 pi over 8. This is going to be 2 pi over 8, but that reduces to pi over 4. This is going to be 3 pi over 8. 4 pi over 8 is pi over 2. 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8, 9 pi over 8. We probably have enough. All right, let's go back the other way. That's negative 1 pi over 8, negative 2 pi over 8, negative 3 pi over 8, and negative 4 pi over 8. And we should be pretty good. Okay, now all you have to do is make these changes to these ordered pairs, and we'll be able to graph our new first cycle. Okay, negative pi over 2, that's an x coordinate. What are we doing to our x's? We're timesing them by a half. So take negative pi over 2 and times it by 1/2. That's negative pi over 4. All right, take your undefined y value and times it by 3. It's still undefined. All right, so now we have a vertical asymptote at negative pi over 4. It's being shrunk in. It doesn't go to negative pi over 2 anymore. All right, let's go to the next one. Take your x coordinate, which is negative pi over 4, and times it by 1/2. That's negative pi over 8. Take your y coordinate and times it by 3. That's negative 3. So now you have a key point at negative pi over 8, negative 3. This has been stretched, right? Vertically, at least. All right, now we go to the next point. Take your x coordinate, times it by a half, it's still 0. Take your y coordinate, times it by 3, it's still 0. right? Take your next ordered pair, 1/4 times it by a half, that's pi over 8. Take your y coordinate, times it by 3. And then last, take your pi over 2, times it by a half, that's pi over 4. Take your undefined y value, times it by 3, and it's still undefined. So we have another vertical asymptote. So guys, if you think about it, it's 1 pi over 4 to 1 pi over 4. That's 2 pi's over 4. That's pi over 2. That's our period. It takes pi over 2 units to create one cycle now. Now, you should be able to make that squiggly curve, and there you have it. All right, and we can repeat it. Sometimes they ask you to show at least 2 cycles, so now it's just going to repeat. We're at our asymptote, so now we're going to -3, then we're going to 0, then we're back up at 3, and then you're back up at another vertical asymptote. And that was 3 pi over 4 to 1 pi over 4. That's 2 pi's over 4 it took. That's pi over 2. That's another cycle, another period. And then everything just keeps repeating. So every pi over 8 units, you have a critical point. And you're done. Okay? All right. They ask you to identify the domain and range of your new tangent graph. So the domain, who are the bad guys? Guys, look for your VAs. Who are the x values that you're not allowed to plug into this function? Negative pi over 4, 1 pi over 4, 3 pi over 4. Obviously, pi over 4 is bad, and any odd integer multiple of it is going to be bad. So we're going to say x cannot be. Our first bad guy is pi over 4, plus or minus. How many units in between each bad guy? Well, like I said, guys, 1 pi over 4 and 1 pi over 4 is 2 pi's over 4, which reduces to pi over 2. So every pi over 2 units starts a new cycle and gets you another vertical asymptote. So pi over 2 is how far apart they are times k revolutions. Now, I'm pretty sure on your homework, this might be a multiple choice question. You just kind of pick which one the domain is. On your homework, they may make you get a common denominator and add these together and then put k in your numerator. I think I remember that from last year, but like I said, this is a new addition, so they may have changed that. So just know that if you're not seeing this, you may have to get a common denominator and add them together, okay? All right, and that's it. Oh, our range. The range. What y values still live on this tangent graph? Guys, where are all the y values still going to on each separate curve? They're still going off to the infinities, so all real numbers. All right, how do we feel, okay? Okay, like I said, you have a graphing calculator. Desmos, I think, is even more beautiful to look at if you have Desmos. It's really, you're not going to be asked to graph anything by hand. It's can you identify this on the online homework, and hopefully you can do that. I think the major thing is, can you at least identify your new period and figure out how many units it takes to create each new cycle? All right, let's try one more. Hey Jay, what's going on, bud?
I have a question. So the original period for the tangent function would be pi?
Yes.
Pi over 4.
Pi. Pi is the period. Pi over 4 makes his subintervals. Pi over 4 is the counting increment on the tangent graph.
Oh,
okay. Okay? Okay. All right, so for this one, now they've asked you to graph y equals -2 times the cosecant of pi over 2x and then -1. So guys, it's got changes all over its function. We've got the -2 on the outside. That's going to affect our y's. Not only is it going to stretch it 2 times as big, it's going to cause an x-axis reflection. So it's going to be a flip over the x-axis. All right, we have pi over 2 times x. That's definitely going to affect our x's, so that'll affect our period. All right, and then we have the minus 1 on the outside that will affect y and shift it down. All right, I'm going to blow your mind a little bit. Sometimes the hardest part about trying to graph a transformation is trying to remember, what did the parent look like? What did the graph of cosecant x look like, right? Hopefully you remember from yesterday that the cosecant and secant were that parabola up, parabola down, parabola up, parabola down. However, guys, as far as cosecant and secant are involved, they're the reciprocal of sine and cosine. So the sine and cosine curve are supposed to be by far the easiest trig functions to graph and work with. So I'm actually going to have you guys graph this as a sine function, and then we'll just flip all of our humps up and down. And I think it's 10 times easier to graph it as sine than it is as cosecant. So watch this. All right, we're going to pretend that this is the problem. Okay, pretend it was a sine graph, not cosecant, pretend it was his reciprocal. Everything else stays the same. All right, so now we're going to graph it as a sine, and we're going to get all of the sine's original information for that first cycle. So guys, if we get his parent, right, y equals sine x. And again, I always try and keep this handy if it helps. All right, what was the sine function's period? What did it take to create one cycle? 2 pi. All right, so if we take 2 pi and we divide it into 4 subintervals, our counting increment is pi over 2. So every pi over 2 units, we have a key point on the sine's curve. All right. Well, guys, can you picture sine? Hopefully you can. Sine looked like that, right? So let's get its original key points. 0, 0. Is that another hand? Did anybody raise a hand? I thought I heard the ding.
I did too, yeah.
You did? Okay, if you need it, let me know. All right, so we got 0, 0, right? We got pi over 2, 1, right? The sine at pi over 2. We got pi, 0. That's this point. We're at 3 pi over 2, negative 1. And then we were all the way around 2 pi, 0. That is a lot easier to remember and put together than it would be the cosecant with all of those asymptotes, parabola up, parabola down. And again, I say parabola, it's not really a parabola, but that's what it looks like. Okay, so this is what our original graph would have to go by. Let's get our changes now. We've got quite a few changes, guys. All right, we have this negative 2 on the outside. That's going to affect y. So that's going to be negative 2 times the y's. That's going to make the y's 2 times as big, and it's going to reflect them over the x-axis. So now you kind of have to picture your sine function being flipped. So now it's going to go down and then up. All right. We also have another thing happening to the y's on the outside. We're minusing 1. So we also have y's subtract 1. And that's just going to shift the whole graph down 1 unit. Doesn't change the size or shape of it, just shifts it down. All right, and then we have a change to the x's. Obviously, the x's are the worst. It's the opposite, and you're always messing with that input. That's the worst thing you can do to a function. All right, so it looks like we're timesing our x's by pi over 2, but in reality, your x's are going to be divided by pi over 2. But guys, an easier way to think of that, when you divide by pi over 2, it's actually the same thing as timesing by his reciprocal. So in reality, let's think of it as the x's are being multiplied by 2 over pi, his reciprocal. Okay? Well, what's that going to do to our period? Let's get our new period. All right, the old period was 2 pi. And now you're supposed to do whatever you did to the x's. So take your old period 2 pi, divide it by pi over 2, which is the same thing as timesing it by 2 over pi. So when you take 2 pi and you times it by 2 over pi, your pi's cancel. 2 times 2 is 4. Guys, your new period is 4 units, like literally the number 4. It'll take from 0 to 4 to create a new sine curve. It used to take 2 pi units, right? That's 6.28-ish. Now it's shorter. Now we've shrunk the period. We've horizontally shrunk the graph. All right, well, guys, what's our counting increment? If our new period is 4, if you divide that into 4 subintervals, what's 4 divided by 4? 1. Guys, finally, we're doing something like, oh my God, we're literally going to count by ones. We're going to count by the number 1, and then 2, and then 3. It's going to be beautiful. All right, so let's get our axis set. 1, 2, 3, 4, 5, 6, 7, 8. That should be enough. All right, -1, -2, -3, -4. Remember, the old period was about 6.28, right? 2 pi. So it used to take from 0 to there to create a sine curve. Now it's only going to take from 0 to 4. Okay, let's make the changes to our graph now. But remember, it's not really the sine that we're graphing, so keep that in mind. All right, so let's make all the changes. Take your x-coordinate, 0, and times it by 2 over pi. That's still 0. Okay, take your y-coordinate, times it by -2, which is 0, but now -1. That's -1. So now we have a point at 0, -1. Okay? All right, now we go to pi over 2. Time out 1 second. I just feel like something doesn't feel right now. I want to check something. Okay. All right, here we go. So now we go to pi over 2, 1. Pi over 2 times it by 2 over pi. Everything cancels. It's 1. Take 1 times it by -2, which is -2, and then subtract 1. Now we're at -3. Okay? Pi, take it, times it by 2 over pi, and you get 2. Take 0, times it by -2, that's 0, but -1, and you still get -1. All right, 3 pi over 2, times it by 2 over pi, and now you get 3. Take -1, times it by -2, now you're at 2, subtract 1, and you're at 1. And then last, 2 over pi. 2 pi. Times it by 2 over pi, and you get 4. Take 0, times it by -2, which is 0, -1, you get -1. Okay, so can you guys see it? I'm not gonna fill it in fully. It's a sine curve that has been stretched, reflected, and horizontally shrunk. So that's what it looks like. So guys, do you remember when you were graphing the reciprocal, right? Each one of these humps, like here's your midline, right? Each one of these humps, right? We had asymptotes where it kind of stopped right here, cutting it in half, and then they flipped down. We had asymptotes here, where that midline was, because where your x-intercepts would have been, and then the hump flips up. So the graph of -2 cosecant pi over 2 x minus 1 is this. Take your midline right through. These are your x-intercepts. So now this is where a VA would be, right where he would have been an x-intercept. He would have been a VA. Right at your midline, he would have been a VA. And now take this hump, flip it down. There's the first curve. And again, remember cosecant was parabola up, parabola down, but there's an x-axis reflection. So now it's parabola down, parabola up. All right, here's your next one, right? See this hump? He would have gotten flipped up when you reciprocate all of his ratios, and now it looks like that. And again, I think it's 10 times easier to work with the sine function, create his first period, than it is to create the first period of cosecant. And all you gotta do is flip up. And now guys, our pattern repeats, right? So we have an asymptote every 2 units. So 6 will be another VA, 8 will be another VA. This point, right, will repeat here, I'll be at -3. This point will repeat, I'll be at 1, and then it'll be another parabola down, and another parabola up, and you've created yet another cycle of this new cosecant graph. All right, If you don't like it, then my only advice is to just get all of the original information for the first cycle of cosecant, use all of his ordered pairs, and transform them. But I think as far as remembering what the first cycle of sine was, that's a lot easier to remember. Okay? Is that okay? Is everybody all right with that? Yeah. Okay. And again, like I said, on your homework, guys, I think you would be silly if you weren't trying to use Desmos or a graphing calculator to help you along. Because we are definitely moving through these sections because of how important it is that we get to chapter 7 and start chapter 7. All right? And that's it. So I did make a homework on this, guys. I believe it's 8 questions. And I am really under the impression that it's multiple choice, that you're just picking the new graph and then inputting your domain and range. All right? Any questions? Are you guys okay? All right. Here's the deal. Because of prom, I may have to take, not because of prom, because of my weird week, I may have to take off tomorrow, guys. It's up in the air. I'm not sure yet. But regardless, the rest of the week, I am giving you to work on your homework, and I'm going to open up the quiz and the study plan. The study plan, I think, is 8 mastery points. I think I'm only going to make you get like 2 or 3. Like, it's literally just there if you want something to review. And then I think I may even open up your quiz, guys. I'm going to leave this quiz open for a few days. Because if anybody wants to get it done before the weekend, if anybody wants to get it done at the end of the weekend, I understand it's prom. I feel horrible enough that I'm even putting it over the weekend. It's just the way the week is planning out. So, I think I'm just going to open it up all now. I'll have the study plan ready to go. I'll have the quiz available once your study plan points are met. And then you guys do it on your own time. And I'll just be here for the rest of the days if you have questions. Is that all right? Does that sound okay? All right. Okay, so I have to, the study plan isn't up. Your homework is up, but I have to get that study plan. I will have it up today, and you guys can start, getting stuff, whatever you want to get done. All right, perfect. Let me double check your attendance, and then we'll be good to go.
When you're done with attendance, I just have a quick question.
Yeah, just hang out for a second, Michael.
Okay.
All right, what do we got? We got, if I say your name, you're good, guys. And if you have any issues, like I know some people are also taking ASVAB testing, please just let me know and communicate with me. All right, we got Jay, Dave, and Kayla. Anna, Jackie, Sky. Mackenzie, Chloe, Javier. Guys, have a great day. Oh, I'm doing it right now. Zach and Vanessa. I always do you guys last. Bye, guys. You too. You too. Seth, Drew, Svara.
Have a good day.
You too, sweetie. I think that's it. Okay. Alyssa was here. Dylan was here. Mark was here. Michael was home. Ella, no. Marissa was here. Casey was here. What's up, Michael?
So I just wanted to ask, is there a domain and range for this?
Michael! Oh, I wish I had let you ask your question. Yes, so the domain, Michael, are you going to be okay if I leave this part on the video? With your, you won't be seen, but your voice will be.
I don't care, yeah.
Okay, your voice will be heard, but they won't see you. All right, the domain would be, well, look at all of our bad guys. 0 is bad, 2 is bad, 4 is bad, 6 is bad, 8 is bad. So it's kind of like weird that we're actually talking in terms of like normal numbers, but technically X cannot be. The first bad guy is 0, and then plus or minus, the next one is always 2 units away from that. So we would say 2 times K revolutions.
Is K capitalized?
It doesn't matter. I think they use a lowercase one, but it shouldn't matter. I think, Michael, that it's going to be multiple choice, that they'll have it written for you.
And it equals it, right?
Yep. Oh, sorry, X cannot equal. Those are the bad guys.
And then the range.
And then the range is going to be, all right, look at your curves, like our parabolas, right? Because technically this dot is not the graph. All right, so it goes from negative infinity to -3, and then there's this huge gap of y values that don't live on the graph. So we're going to go from negative infinity, not including it, to -3, but including -3, because that is a point on the graph. And then union that with, now where does the range pick back up? We have this huge gap, and then the y values pick back up at 1 and shoot off to infinity. So then it's gonna go 1, 2, infinity, including 1, but not infinity.
All right, thank you.
Oh, I'm so glad you said that, Michael. I'm gonna send a reminder out that I did that with you so people will know, okay?
All right, thank you.
Have a great day.
You too.
Bye.